In today's video, we're going to talk about how to graph quadratic functions. Now, there are three different types of quadratic functions. So the first type that we're going to focus on today is ones that are in vertex form. So vertex form. Remember, f of x is the same thing as the letter y, so it could say y or f of x equals a parentheses x minus h, close my parentheses, quantity squared plus k. Now we call it vertex form because you should be able to just pick the vertex right out of the equation. So the vertex is found by h comma k. Hopefully you notice that h in the form is a negative, but when we came down here next to vertex, I wrote it as a positive h. So if you can remember transformations, we talked about if it was inside, it was opposite. Or if you don't remember that, then you could just remember always change the sign of h and keep the sign of k. Now remember, quadratics, when you graph them, are going to be a U-shape. And a U-shape, if you were to draw a dashed line right down the middle of the U-shape and fold it over, then the left and the right side should match. And this lovely little dotted line, that is what we call the line of symmetry. Or I like to call it LOS for line of symmetry. Line of symmetry will always be a vertical line, so that's why it says x equals. And then it'll always go through the x number of the vertex. So you'll notice that it just says x equals h. Now, we're also going to ask you to look at the U shape and identify if it's a maximum or a minimum. If the U opens up, which means A is a positive, then it has what we call a minimum, because this dot right here is the lowest that the graph will go. If your A is less than 0, so that means if it's a negative number, then it's going to open downwards. And if it opens downward, then the vertex is the highest point, and that's why it's called maximum. So let's just jump right in with graphing. So the first thing I like to do is identify the line of symmetry. So LOS. Remember, LOS is always x equals. And then what you do is you look at the number inside the parentheses and you change its sign. So inside the parentheses is positive 1, so we change that to negative 1. Then vertex, which I'm going to call V. So remember, vertex, change the sign inside the parentheses to negative 1, and then keep the minus 4 at the end. So now I'm going to go plot my line of symmetry. I'm going to put a dashed line because that's not really part of the answer. That just helps me fold. And then I'm going to plot my vertex. So left 1, down 4. Now I want to get some other points to help me draw in the U shape. So I'm just going to make a little t-table. Now you can pick any numbers you want on your t-table, but so that we are all consistent, then what I would say is we need to pick at least 2 points that are on the right side of the line of symmetry. So remember, my line of symmetry goes at negative 1. So what's to the right of negative 1? And that is 0. And then the next number to the right of 0 is 1. So now that we know our x numbers, we're just going to take those and plug them into the original problem. So I'm going to go 3 parentheses 0 plus 1 quantity squared minus 4. So then I would type that into my calculator just like I have it written, and you should come up with the answer of -1. Now the next time I would substitute in 1. So I would type in 3 parentheses 1 plus 1 squared minus 4. And if you type that into your calculator, you should get 8. So now I'm going to go plot 0, -1. And I'm also going to plot 1, 8. Now this will give me the right half of the U. To get the left half, what I'm going to do is I'm going to look at this point, and you're going to notice that it's only one space from my dashed line. So I'm going to go directly across, and I'm going to go one space to the left. The top dot, it is 2 spaces. So go over 2 spaces. And I got my other dot. So remember, just pretend like you fold on the dashed line and your 2 dots should be mirror reflections of each other. So then I just get to draw in my U shape. And the last thing I have to do is tell if it's a min or max and what that value is. So does everybody notice it opens up? If it opens up, then the vertex is the lowest point. So that means it's a minimum. And what is the lowest that the graph goes? So what is the y number? What's the lowest y number? And that is -4. Now you'll notice that the minimum value is also the y value of the vertex. And then if you don't have a picture, does everybody notice the a number is 3? And 3 is a positive number, so that means it's going to open up. So you could also tell it that way. So let's go try another. Line of symmetry. X equals, switch your sign, +2. Vertex, switch your sign, which makes it +2. Keep your same sign, which makes it 3. Then I notice my A is a negative, and since my A is a negative, that means it's going to open down. So if it opens down, I know it's a max. And the max value is the y of the vertex, which is 3. Or if you want to wait and do that after you have the picture, that's fine too. So here I'm going to make my little t-table off to the side. Okay, so line of symmetry is at +2. So here's my dashed line. I'm going to plot my vertex, which is 2, 3. Now remember, your vertex should always be on your line of symmetry. What's to the right of 2? Well, that is 3, 4. Now you have to have at least 2, but there are several more that will actually fit on the graph. So I will list them all, but you need to make sure that you have at least 2 numbers on your t-table. So then I would go to my calculator and I would type in 1/2 times 3 squared. No, sorry. Let me erase that. So I would do 1/2 parentheses 3 minus 2 squared plus 3. And if you type that in your calculator, you get 2.5. Then I would do -1/2 parentheses 4 minus 2 squared plus 3. That gives me 1. And so forth. I did some more, and I came up with -1.5, -5, and -9.5. So I'm going to go ahead and plot these. So 3, 2.5. And then I'm going to reflect it over. So 4, 1. And then I'm going to reflect it over. 5, negative 1.5, and then reflect it over. 6 is negative 5. Reflect it over. And the last one I have is 7, negative 9.5, and reflect that over. And then here is my U shape. Okay, the next question, we're going to take a little break from graphing. On this one, I'm going to tell you the vertex, and I'm going to tell you a point that is on your U shape. So in the vertex, remember, negative 1 is in the H spot, negative 4 is in the K, and in the random point, you have your X and your Y value. So remember, vertex form is y equals a parentheses x minus h quantity squared plus k. And you're going to plug in for everything except for a. Okay, we always have to do the algebra work to find a. So for y, I'm going to plug in negative 1 equals a parentheses x is negative 3. H, well, remember, h is negative 1, but when I write it, I have to do the opposite, or I have to switch it. Don't forget to switch h. So I'm going to write it as plus 1 quantity squared. K is exactly the same, so minus 4. Inside the parentheses, I'm going to do negative 3 plus 1, which is negative 2. If I square negative 2, it becomes positive 4. Then I'm going to add 4 over. So I get 3 equals 4a. And then I'm going to divide by 4. So I get a to equal 3/4. Now on your final answer, you just have to plug in h, k, and a. So y equals a, which is 3/4, parentheses x. Remember to switch the sign of h, so plus 1, quantity squared, and k is the same, so minus 4. Okay. Last thing we're going to talk about here is I'm going to give you some word problems, and I'll also supply you with a picture of the graph. And what we have to do is we have to look at the graph and interpret what the questions are asking me to answer. So on the first one, it says here that we're looking at an arch of a bridge, and they give you the equation. They tell you x is the horizontal distance in meters, and y is the distance from the base of the arch. So we have two things we want to do. The first thing is we want to find the width of the arch. So my arch is pretty, I know it's pretty close. We're just going to kind of estimate it here. And I'm going to say it starts at 0. And then over here, we're going past 100. And if you notice, the scale on the bottom is by 5. So I'm going to estimate this one to be at 105. So the width is the distance between them. So the distance between 105 and 0 is just 105 meters. Part B, how high does the arch of the bridge reach? Well, how high is asking for the max value, the max height. So I'm going to come over here and I'm going to find my vertex. So does everybody agree this looks like it's my vertex right here? And then I'm going to follow it across, and I'm going to figure out the y value. And once again, we go by 5s. So to me, it looks like the max height is 45 meters. Okay. Let's try one more word problem. On this one, we got a hover calf. And they give you the equation, and they tell you the height is in meters, And then the x-axis is in seconds. So part A, how many seconds after takeoff will the hovercraft land on the ground? Okay, so once again, taking off at 0, landing at 9. So the distance between 0 and 9 is 9. So is everybody okay? The answer for A is 9 meters. B, max height. Okay, so for max height, once again, go find the vertex, which this looks like the vertex for me. And then what we're going to have to do is follow it across. This top line is 110. So I'm going to guess that it is about at 108. I did put about there because it's not exactly. So if you did have 1 or 2 off from that, that would be fine as well. C, how many seconds will it take the hovercraft to reach the highest point? So this time I'm looking at the vertex, but instead of asking for the highest point, I'm asking for the time. So I'm going to follow the vertex down to the x-axis, and that's 1, 2, 3. So I would say 3 seconds. And then the very last one. What is the height of the platform that it's taking off from? Well, that is asking you the y-intercept. Okay, so starting point is always the y-intercept. So I come over here and I figure out where it crosses the y-axis. And to me, it looks like it's a little bit above 80. So I'm going to say about 82 meters. And once again, there could be a little give or take on that one. Now, the next page, this is just a handout that you'll be given that has a table for the word problems. And it kind of helps you decide like, oh, if the question asks how high does the object go, then I know that is asking for the max value. Or if it says, when is the object at max height, that's asking for the line of symmetry. So this is just kind of like a little chart that's supposed to help you interpret the word problems that you get to look at. And then down here at the bottom, I've given you a picture of a quadratic that opens up and a picture of a quadratic that opens down. And we have the line of symmetry, or sometimes some books, instead of line of symmetry, they'll call it axis of symmetry, but they're the same thing. X-intercepts are pointed, Y-intercept is pointed, and then it also tells you the vertex and whether it's a max or min value. And then if you're curious, at the bottom, you will see here are our 3 forms that we're going to be learning for graphing a quadratic. So that's it.